Hi, everybody. Thank you for spending this hour with us. This is the State Demography Office Spring Webinar Series. We're going to be talking today about the American Community Survey and census data. This is our outline. First, we will walk through some of the materials that are available on the SDO website, and then we'll do a relatively deep dive into the American Community Survey data set. We'll talk about the margin of error, how you get this data, and then some table operations, and then talk a little bit about the public use microsample. And then we will have an opportunity for some questions, and then we'll talk a little bit about an analysis example that illustrates how to use ACS data to characterize neighborhoods. So when we talk about census products, we're generally talking about 4 different kinds of surveys and data products that the Census Bureau generates. The first is the decennial census. This is a once a decade enumeration of all the addresses in the United States, and it produces data mostly for political redistricting. This is data, it's age, race, and sex mostly. And then that information provides baseline data for population estimates, which are updated every year for every geography using demographic methods. These are accounting for births and deaths and other characteristics. The American Community Survey is really sort of the broadest product that the Census Bureau produces. It's an annual sample survey of addresses, and it provides a lot of information about social characteristics, income, language spoken at home, housing characteristics, etc. This data set is the one that we query the most when we get requests from data users, and it's important as to become familiar with this data set, and hope that in the course of today you'll be able to access some of the data that you need. And finally, the Census Bureau supports multiple economic and business surveys. If you need access to that data, by all means contact us, and we will make sure that you can get access to the information that you need. So we're going to go off to to our website and walk through some of the materials that we have posted on our website. These links here give you the direct links that you need if you don't want to work through our website, but it highlights some important resources that we have. So this is our website again. Now we have these tables here on our homepage, that can be customized for counties. The first 4 of these tables are tables from our estimates, the estimates that the State Demography Office develops. These last 2 tables provide information from the American Community Survey. When you click on a link in those 2 tables, it will take you to data.census.gov, which is the ACS data portal for the selected county that you were looking at, and for the proper data file that in most cases it's the ACS 5-year data file. And then you can customize these tables by clicking on the Geos button here and select additional geographies, whether it's counties or municipalities, places, or whatever. You have a very, very long list of different geographies that you can add to these tables. Then once you have your table customized, you can download an Excel file, a CSV file, a zip file, and then access this information for whatever product you're creating. Now, in addition to these tables, which is just a very subset of all the tables available in the ACS, we have resources under this button here. It says the Census Data and Resources button. This takes you to the Census Resources page. The first thing I want to highlight are the American Community Survey spreadsheets. These are a collection of spreadsheets that we develop for each ACS 5-year data release. And this provides key information for counties and municipalities by from different tables and using different breakdowns. And the contents of these tables are based on the questions that we have received in the past. Additionally, under the ACS visualizations, maps and applications are a lot of different applications and maps that we have developed, including the Census SDO Census API. This provides you with data sources for all of the ACS 5-year releases and information from the last 5 decennial censuses. This information is accessible by table number. So you would click on a table, you can customize your geography down to the census block group. And then if you click on the Get CSV button or the Get JSON button or the GeoJSON button, you will get a spreadsheet that contains the contents of the particular table that you selected. Down here, we have different visualization tools that the Census Bureau has developed. And then down here under American Community Survey applications are 3 documents that are essential documents to understanding what is in the American Community Survey and understanding how to use it. The first is the table shells document. This is a listing of all of the ACS tables and all of their contents. And as we'll see, this is an essential document for finding a table that you need and accessing it. So I encourage everyone to download this spreadsheet and keep it handy for yourself. Additionally, you will have the ACS subject definitions. This is information about the code lists and how different topics are defined. Plus, there are instructions for applying statistical tests and working them with the margin of error, and there are additional tools that you'll find helpful. And then finally, the other essential document is the ACS handbook. The ACS handbook provides detailed examples about how to manipulate ACS data and how to conduct statistical tests, how to aggregate and collapse ACS tables. Now, there are a lot of specific documents on this page. The one that I encourage you to download and become familiar with is this understanding and using ACS data, what all data users need to know. And you can access this from our site here. Okay. There we go. So one of the things that is true, demographers love geography. Everything that we present, everything that we work with is defined by geography. And the Census Bureau maintains a fairly complicated geographic hierarchy. If you take a look at the diagram here on the right, you'll see that there are geographies that are completely nested within others. So if you start, say, at census tracts, all census tracts are nested within counties, all counties are nested within states, and so forth. Now, there are other essential important geographies that are not on this spine. They're called the off-spine geographies. Municipalities and places, they often span counties. For example, in Adams County, just about every municipality is also in a neighboring county. Okay, and when you access that data, you will get data for that entire municipality, but not necessarily for the components by county. Another common geography that we work with and get requests for are zip codes. And those are based not on population counts, but on postal delivery routes. And those span both state boundaries and county boundaries. And it's really interesting dealing with those, because sometimes you will get a zip code for a county, say in El Paso County, but the name associated with that zip code is in Pueblo. And that's because the name associated with this is the location of the post office that zip code serves, not the geographic area that the zip code serves. And then there are other non-standard geographies that are not supported at all. We'll be talking about neighborhoods later on in this presentation, but often when we work with different organizations, they will be in these non-standard sorts of geographies. For example, a program may serve one county and then a sliver of a neighboring county. And one of the challenges that we have and that we work with our requesters to solve is, how do we get all that population represented in the data that we provide them? So these are things, for you to think about when you're thinking about what kind of information you need to collect and what kind of information is available. Okay. So the American Community Survey is really our primary source of data about social characteristics. This data is provided in tables, not records, with one exception, which we'll return to in a moment. Now, the tables can be manipulated. Categories in a table can be collapsed, table geographies can be aggregated. But the approach to doing that work is a little bit different than what you may have been used to if in your statistical class, in a stats class, where you've used individual record data. Now, when we talk, and we'll return to this in a moment, when we talk about the American Community Survey, each year there are 2 data sets produced. There's the ACS 1-year data set, which provides single-year estimates for populations of 65,000 or more. And then there's the ACS 5-year data set, which provide a 5-year period data down to the census block group. Most of the requests that we get are for smaller geographies. So most of the time when we provide data for you is from the ACS 5-year data. So this chart kind of describes the difference. First of all, for the 1-year data, they will take a single year of data receipts of completed surveys and run it through its data cleaning and data weighting and data tabulation processes to create a data release. For the 5-year data, they combine 5 of these single-year data sets together and run them through the same processes, okay? Now, in practical terms, what this means is for ACS 1-year data for places with more than 65,000 people in them, you can create a single-year trend line, okay, by comparing each individual year to the subsequent year. In the ACS 5-year data, you get what is called a period estimate. It's the period estimate that represents 5 years of data. And if you're going to make a comparison, you can only compare non-overlapping periods. For example, the most recent ACS data is the period from 2018 to 2022. The proper comparison is the ACS 5-year data from 2013 to 2017. If you compare other vintages and other ACS 5-year products, you will have overlap between the two points that you're trying to compare. Okay. So I want to talk a little bit about the margin of error. This is a statistic that seems to confuse my colleagues in DOLA, and I want to talk a little bit about what this means and how to interpret it. We're going to have to go into Stats World here. Stats World assumes that every census is perfect. You collect data from everybody and that every sample is complete. So let's just deal with that. So a census collects data for all elements in a population, whatever, addresses, people, whatever. And it allows for a direct estimate of the characteristics of that population. Now, a sample selects a subset of elements in the population. And the way that these elements are selected allows you to infer the characteristics of the population from the characteristics of the sample. Now, in this assumption, there's a couple of other assumptions. Strictly speaking, we never really know what the characteristics in a population are because we never have enough time or money to collect information from all the elements in that sample, in that population. But we do know what all of the characteristics in our sample are because we've collected data from everybody who is in that sample, every element in that sample, right? And the task is to take the known characteristics of the sample, which we've analyzed and measured, and apply it to the unknown characteristics of the population. So we do that by looking at how the individual elements are selected. Now, because a sample doesn't collect from every element in a population, we assume that the values in a sample will differ from those in the population. And that difference is known as the sample error, okay? Now, because of the way that elements in a sample are collected, it's possible to estimate the size of that error. And in the ACS, that sample error is called the margin of error. Other statistics that you may be familiar with that are similar to this are the standard error and the confidence interval. Okay. And the size of the margin of error is a function of the number of sampled elements. So in this example here, we need to think about the margin of error is a measure of sample precision, of estimate precision. It does not mean that the estimate is invalid. Okay. The way that things are sampled, we see here in the example here from Greeley, where median household income is $69,338, and the margin of error is, $4,588. The way that elements in the sample are collected, we have a 90% confidence interval, a 90% confidence that the true value for median household income is between $64,750 and $73,926. So if you take a look at the diagram here on the right, this is called a sampling distribution. It's a theoretical distribution of samples. The idea is that if you were to take an infinite number of samples from a population, in this case for Greeley, and calculated the median income that you calculate, the estimate, the 69,388, would be the value that has the highest probability, the highest likelihood of occurring. But there would be variation around that estimate that are defined by the value of the margin of error. What seems to confuse folks is that I will hear people say, I can't use a particular estimate because the margin of error is too large. And when I hear that, I get the idea that they're thinking that this estimate is somehow inaccurate, that it is invalid. But really what the margin of error is telling you is how precise that error is, how precise that estimate is, excuse me. The more observations that you have, the narrower this margin of error will be, but the estimate will remain the same. So as you're thinking about this, when you hear the term margin of error, don't think error as in wrong. Think about error as being a measure of the precision of an estimate. Okay. Now, when do we use this? In most cases, we don't need to worry too much about the margin of error. It is important to use the margin of error when you're making comparisons, when you're comparing two geographies to see if they are statistically significantly different. Pardon me. Or when you're comparing a single geography over time. Now, in the ACS handbook that we talked about earlier, there are really good examples about how to determine whether two estimates are different from one another. And though these tests take into account the imprecision of particular estimates. Now, in the materials that our office produces, we always include the margin of error calculations because we are concerned to produce an accurate and complete tabulation of data. In your work, you may not need to worry that much about the margin of error, but there are a lot of circumstances where you do need to worry about it, particularly if you're trying to say that area 1 is different from area 2. Okay, so we're going to get out of stat world right now and talk about how we get this data. The ACS data is available at data.census.gov. The site provides access to census and ACS data tables, and also to maps and to profiles and a lot of other products. It supports a keyword and a table search. However, the keyword search is kind of problematic. Okay, but this data is available from a lot of different sources. The SDO API that we walk through, if you're using different statistical programs, there are lots of ways to get a hold of that data. And if you are working with more than one table or more than one geography, you may find it to be more efficient to work with some of these other tools than to walk through the steps we're going to describe right now. So here is our method that we recommend for getting data from data.census.gov. It starts with the table shells, okay, which is the listing of all the detailed tables, the B and the C tables, and all their contents. I encourage you to search through the table shells and find a table that meets your needs, and note the table number, which is in column A of the spreadsheet. Then go to data.census.gov and enter that table number in the search box. That will guarantee that you get to your selected table. And then you can customize that table by selecting the appropriate data set and the geographies that you need. And then you can download the table using the CSV and Excel download functions that we talked about when we were out on data.census.gov. So you have these tables, they're great, but often they're not exactly what you need. So sometimes you have to manipulate these tables. You can collapse categories, you can aggregate geographies, and regardless of what you're doing addition. Okay, estimates can be added together. You need to combine the margins of error. The way that you do that is by taking the squared values of the margin of error, add them together, and then at the very end of your table manipulation, you take the square root of that sum of the margin of errors to get a final margin of error. Now, I encourage folks to manipulate the margin of errors as you're manipulating estimates, just so that you don't have to go back and repeat yourself. But if you're not, but as we mentioned before, the margin of error may not be necessary for a particular project. So here's an example of collapsing categories. This is a table that has got two age panels in it, households 45 to 64 and households 65 and older. And we're going to combine them to create households 45 and older, right? But the household was age 45 and older. What we do for each category in those panels is you add together all of the estimates and the margins of error. Now you can also do this for, say, the income categories here. If you wanted to create a new category of income between $10,000 and $19,999, and it's the same operation. When you aggregate geographies, it's the same operation. Okay, you add the geographies together, and then you add the squared margins of error together, and then you, at the end, you take the final margin of error, which is the square root, and that gives you information that you're going to use for whatever your next step in your analysis is. Now, as I mentioned, the ACS is a collection of tables. Sometimes the tables just don't provide what you need. In that case, there's an additional product called the public use microsample data, the PUMS data, and it's a subset of ACS data records. And you can analyze that by going through, a statistical program to create, new cross tabulations. Using the PUMS data is appropriate for state level analysis and for analysis of geographies with more than 100,000 people. These 100,000 people areas are called PUMAs, but they can be problematic because they don't respect any other census geography. Additionally, when you start to use this data set, you need to understand statistical weighting in order to calculate a proper margin of error. If you're going to go and work with PUMS data, please come and talk to us, and we can help you get started. And we're always available to provide support for your analyses. Okay, so I'm going to pause here for a moment and see if anybody's got a hand up or got some questions. Just a second here. Okay, one person in the chat. Okay, so let's see what else I got here. Okay, so someone sent in a question here in terms of data quality. Do you recommend not using certain geographies? The answer to that question really is we don't make any judgments about quality, but knowing that for smaller areas, information is going to be less precise than it will be for larger areas, just as a function of the number of addresses that have been sampled. In many cases, however, we recommend caution if you are looking at geographies below the census tract, because first of all, a lot of data tables are suppressed below the census tract for privacy reasons, and also the margins of error get very big, and then you need to think about whether a estimate that is sampled from, say, 10 or fewer addresses is worth the effort you need. So any other? I don't see any other hands up. So let me go forward with the example here. So the analysis example that we're going to talk about very briefly here is about characterizing neighborhoods by income and race and ethnicity. So last October, we received a question from the Denver Public Library. It asked for neighborhood data by income, race, and ethnicity for the city of Denver for the population age 50 and older. So working with this requires identifying the age categories that you need that are available, finding a table series, and finding dealing with race and ethnicity categories, and then aggregating census tracts. So We have worked out resources for this example. We have a detailed discussion about about ways to generate neighborhood data from the ACS. We have the Denver Neighborhood Track Crosswalk, which is really a unique tool that the city of Denver provides that maps identified Denver neighborhoods to census tracts. And then we've got a fully worked out workbook, an example there. So we want to talk a little bit about some of the decisions that we have to make as we get ready to do this work, but you can download all these documents on our training and webinar page. So the first thing that we need to do is identify the table series. We look through the table shelves, okay, and we identify this table series B19037 to B19037I, which is age by household income in the past 12 months. The suffixes here indicate that there are individual tables for each race group, race and ethnicity categorization, okay? This data provides information for the householder based on the household income by the age of the householder, and it creates a three-way cross tabulation. So the first question is, can we get the age categories that the request asked for? And the answer really is no. They wanted persons 50 and older, but however, this table breaks out panels for householders 45 to 64 and 65 and over. So this is a decision point that a program needs to make about whether you look at a broader age category or a more narrow age category. For example, whether you combine the householders 45 to 64 with the householders 65 and older to get a broader age category than what they requested, 45 to and older, or whether you just focus on householders 65 and over and get a more narrow classification. The second thing to deal with is the table series by race and ethnicity. Some ACS tables break out results by race and ethnicity categories, but not every table does. In the situations where they use race and ethnicity categories, each race and ethnicity category is in a separate table. So to assemble results by race and ethnicity, you need to access every one of those tables. And this is where I really recommend using a statistical program, because you can then program your code to produce your desired outcome table once, rather than having to do all that calculation 10 times, because every one of these tables is separate. In the example materials, we looked at 3 of the subtables for no reason other than it's not having to summarize all 10 of them. Okay, but you can see here that each of these tables addresses a different race and ethnicity category. Now, finally, you need to aggregate geography, and so this is an interesting question, because neighborhoods are not supported by the American Community Survey or the Census Bureau. Frequently, neighborhoods are collections of census tracts, and Denver, like I said, is unique because they maintain a set of statistical neighborhoods. And in the crosswalk that is up on our website, you can see the census tracts that are associated with a particular neighborhood. In For other Colorado cities, you will find online maps that you can use to focus in on particular areas that identify a service territory. And then by following the link here at the bottom of this slide, go through the methodology laid out there in there to find the corresponding census tracts. Now, smaller communities may not have enough tracts to identify neighborhoods, and that is another consideration that you have to take into account. When you're working with census tracts, you have to use 5-year data. Census tracts are too small. They have an optimum size of about 44,000 people, and that's a lot smaller than the 65,000 person threshold for the ACS 5-year data. Excuse me, 1-year data, pardon me. So I've thrown a lot at you. I appreciate you hanging out, and we'll have some time for any additional questions. We provided an introduction to the ACS. Using the ACS can be complicated, and we've covered a lot. We encourage folks to understand what tables are available by looking through the table shelves, and then try to match your program criteria to the available tables, knowing that you may have to, make a decision one way or another in using the information from the ACS. And then we talked a little bit about how you manipulate tables, and then a little bit about the margin of error. Now, as always, we're here to help you. If you have any questions about what is going on, or if you need assistance in putting together some materials, whatever it is, we're always available to talk to you, and we encourage you to reach out to us. On our website, we have a questions button that sends us questions, and then we will get back to you and try to help you get to a solution that works for your particular geography and for your particular information needs. So I'm going to let you stare at my my contact information here, and then looks like there's another question in the chat, and we will take a look at that. So I'd like a copy of this. The slides are presented and posted on the webinar and training page. The recording will be posted probably early tomorrow. And as always, we're available to talk to you all. Have another question? Okay, so the question is, if the ACS reports a loss of population in a community when it is a growing community, how can a municipality direct the error? Well, so as the ACS, there's a couple of things. First of all, we do not recommend using the ACS for population totals. If we have population estimates for every community on our website that the State Demography Office develops. When you look at a statistic from the ACS, you also have to take into account the margin of error to see if, say, between 2 5-year periods, the difference between the population numbers from one period to the other is statistically significant. It may not be. So that's something to look at. Generally, we have better data for population estimates for communities, and we encourage you to use that. Again, if you want to talk about this in more detail, please send us a note and we'll get back to you. Are there any other questions? Okay. Okay, a lot of things in the chat here. Yes, right. Okay. Okay. So there's a question here about populations that are urban versus rural. We have an entire um, blog post about that, including information about different about the new rural and urban classifications. That blog post is part of the State Demography Office Crosstab series. It's available from the in the bottom left-hand panel of our homepage. So please take a look at that. And if you have any additional questions, please get in touch with us, and we'll be willing to work with you to figure out the answer for you. Okay. All right. So any other questions? All right. Well, thank you very much. I do want to make a pitch for the next State Demography Office webinar, which will be on June 12th. And there we're going to talk in some detail about population estimates and forecasts that we generate. So, okay, let me okay, well, thank you very much. And I'm going to end. I got more messages here. Here we go. Okay. Yep. Okay. I think we've got them all. So thanks again. And we'll look forward to talking to you next month.